All right, welcome back. So moving on, we're going to go to built-in functions. Now, built-ins, really useful thing with Python. Lots of languages have these. They vary a little bit from language to language, so just be aware of that as you move forward. But built-in functions are things that are very common things that you would need in a language. And in Python's case, the people who made Python said it would be really nifty to have these ready to go, right? Things that people use all the time, instead of them having to write this stuff out every time to check, right? That instead we have them ready to go and they can use them very quickly, right? But this is part of where, so our if and our for loops were kinds of built-ins. What we're having here is going to be lots of other tools, and you don't have to have them all memorized at the end of day one, but I highly recommend going back every day as you go through this course and rereading about just a few of these, right? Reviewing these Python notes for 10 minutes a day, every day, will take you miles because you'll remember more of the tools. And again, one of the things that happens when you are aiming for fluency in a language is that you're able to use those words, even ones that you don't use every single time. And part of the way that you kind of test your fluency and get really good at something is by moving into those scenarios where it's not just the basics, right? Where you're using some of those other edge case type items more and more frequently. So things like these are going to be stuff that you don't use in every single function that you write, but when the time comes, you're going to really wish that you had these memorized to some degree because it will take you a long ways. So we're going to check this stuff out. And here we go. So range is really cool. We actually have been used kind of a dumbed down version so far. There's like a shorthand version that we've used. And so we've got, the way that this works is you have range and you've got start, stop, and step. All right, what on earth does that mean? Okay. Well, so far we've said for I in range 20, right? We've got print I. Now what this does is actually just says it defaults to 0 for the start, and it stops at 20, and it defaults to 1 for the step. But that stuff we don't see. We didn't write that in, okay? So when I put this in here, sure enough, it starts at 0, and it goes up by 1 step each time, from 0, 1, 2, 3, 4, 5, and it stops when it gets to 20, and that's not inclusive. That doesn't include 20, okay? Now, we can add stuff here. We can say, what if I want to start with 2, right? And it actually knows that start and stop come first, and step is still defaulting to 1. So now we started at 2, and it's still going up by 1 the whole way. And then we could also have this 2 at the end, and now it will go up by 2 steps each time. And now it's just giving us even numbers. If I were to do this at 1, it will give us the odd numbers, right? Or I could go up in 3s. See how that works? So that is how the range function works. Very useful for saying I want to do something this many times, this number of times, right? Cool. On to length. Length, we'll check the length of a variable, right? So name equals max, right? Length equals len name. Print length, and that should be 3. Now, in this case, you could also just say, why not just print 3, right? Because I know what it is. I can count. But what if we did this? Give me the name of your favorite book, right? Give me the name of your favorite book. And I had a Lord of the Rings reference earlier, so I'll do that again. Lord of the Rings. Okay. And now it says 17. There's 17 characters here, right? And that makes it flexible, right? Whatever input we give it, it will count the length for us, because maybe you don't know what the length is. So if somebody else were to run this piece of code, it would tell me the length of what they put in. Very useful. Help! Help, help! I need somebody. All right. Singing the Beatles. Man, stop it, please. All right. So help using this function to view more info about a Python function. And it will end up giving us a docstring, okay? So help for range will tell us everything we need to know. It gives us actually the documentation from Python about what range does, okay? So we've got range, we got an object, the stop, all this other stuff. We don't know all of that, what that means just yet. okay? But you can see it says return an object that produces a sequence of integers from the start to stop, which is exclusive, by step. So, and then all the little things that are in there and how it works, okay? Data descriptors defined here. Lots of stuff going on here, probably way more information than we need to know right now, but if you're ever like, I need to know what this is, you can do that, right? How does len work? Okay. Return the number of items in a container. That's a much easier one. Pretty cool, right? Isinstance. This is another really nifty one. This is one that I had somebody just today saying, hey, Brandon, how do I do this? How do I check and see if something is this? How do I filter out everything that's not this? Okay. Well, isinstance is a great way to do that. Okay. So print isinstance, and then I'm going to have, I should tell you first what the syntax is. Okay. Check a variable to find out what object family or data type it belongs to. Okay. So the syntax is instance, then your variable, and then the type you want to check it to be. Okay. So we have print is instance, right? 4.5, and then we have int. Now you should be thinking that's not an integer, that's a float. That would be true. So if, well, first of all, we can just print it, right? So it says false. And we could also do this with an if statement, right? Say if is instance 4.5 float, then print this number is a float type. Okay, so that's a nifty way that we can do that, right? Again, you could use this as a variable, right? So we're going to say num equals input, pick a number, right? And then I can say if num, I would say if is instance num int print f, or else we could say print f num is a float. Okay, and now I could say 4.5. It says it's a float, and it knows, it can tell us, right? But this is just that should just be a number. Part of the way that this works out weird is 4 is not a float. Why are we reading? Let's just, oh, I know why. I know why. Because this, what do inputs always return? What do they always return? They always return a string. So we have to write a lot more code here, and I don't feel like doing it right this second. But you could have that. Now it would say int. Problem is, if I did this again with 4.5, you have a value error because you can't make a float into an int. So you have to write more code to sort it out. But anyways, I think you understand the isinstance thing specifically right now, and how that works. It just checks to see if it is what it says it is. But that's why this input thing would really cause us some problems. I'm going to get rid of that. And we'll go back to just doing this manually. All right, so now in 4, it says an int. If I add the 0.5, now it says it's a float. We'll add exclamation mark to keep it peppy. All right, cool beans. Abs, that's absolute, okay? Not like six-pack abs, okay? So the way with this one, it's the same thing as in regular math, right? Where you have the absolute value of -5 ends up equaling 5, right? It's the absolute value. It's how far that thing is from 0. This can be very useful for if you are trying to run through a whole list of things and you want to make sure that they're all positive, or if you have like edge cases where you're like your numbers are supposed to be positive, you have one that's negative, right? And you can cancel that out by using the absolute value here, right? Print abs -5. This is how you would write it in Python, and it will give you the value 5 instead of -5. Pretty cool. try and accept. This is really useful as well, especially once you start writing more complex code, right? Or if you have lots of input from users, right? And this would have been helpful for us with our isinstance thing, where if it gives us an error, we can do something else, okay? So try will say, hey, I want you to do this, but if it doesn't work, then we're going to say something else besides just throwing an error, right? So if, for example, you want your users to give you a string, okay, and they don't give you a string, and it throws an error because of that, right? Then you say, hey, you're supposed to give us a string, please, right? It will send that back to the user instead. Very cool. Let's look at an example, right? Use this to log out graceful and useful error messages, okay? And it doesn't stop the program either. Neato, okay? Because otherwise your errors will stop the program completely. It'll bonk, and users will just say, why isn't it working? I can't see it. And your code will be like, I have an error, and users can't see that, and you can't see that. It's a disaster, okay? But this way, we'll actually be able to send them something and send you something that will tell you exactly what's going wrong, especially when you're running more ornate applications and websites and things like that. Because where do errors from websites go? We'll find out. All right, so try number test equals 0. Input num equals int input. We're going to do guess a number. Okay. Now, if they give us a string, what will happen here? An error. Okay. If input num does not equal input num plus number test, and so we're going to be adding whatever their value is to this number test. Okay. And if those are not equal, then we're going to set input num equal to that new number. And we're going to print and the string version, this needs to be a single one, plus string. I can get rid of both of these because it's driving me nuts. Plus string of input num. Okay. However, if that doesn't work, we're going to print that didn't work. Change your input to a number. Okay. So now when we run it, if I say applesauce, that didn't work. Change your input to a number. But now if I say number 5, guess number 5, apparently that did not work. So input num did not equal input num plus number test. Well, it should have. Try 0. That didn't work either. Odd. That's okay. Let's get rid of this. Because basically what we needed to see is whether or not that worked, right? And then we could just print number is, and then we do plus, actually it should already be a string, input num, right? Let's get rid of this. Guess number 5. Ooh. Oh no, I see why I should throw an error. So the reason it threw an error is because we changed it into an integer, and then I tried to add it to a string. So it still threw an error, just a different kind. Okay? Even though I did do the right thing. So again, you got to be careful with this too. Right? String, input num. Now it should work. Your number is 5. Okay? But again, if I put in applesauce, that didn't work. Change your input to a number. Okay? So that should work. And also if I do a float here, because again, it will throw an error because it's trying to make it into an integer. All right, so that's how try and accept works, but you notice that it didn't break my code. If I didn't have that, let's take just this and put it up here. And we're going to tab them both backwards. And then I'm going to comment all of this stuff out and run it now. Error. Problem. Okay. So using the try and accept thing allows us to get away with not having that problem. And it lets our code continue running even if there is an error, which is useful. Okay, and obviously you don't necessarily just have to print things. Okay, you can do all kinds of other stuff with your accept, and that works out just fine. Alrighty, 15 minutes in, we're going to look at some lists here, and then I will send you on to do your work. We have... Actually, that's not true. We're going to do lists in the next video. I'm gonna wrap that up for now, just for time. I think lists will take a little bit of time to work through, so I'm going to cut it there, and I'll see you all in the next video. Later.